I'm teacher Marsha, so your special and beautiful tour guide for today. So today, we are going on a school trip, so woohoo! Who's excited? Because I know I am! So we are going to a margarine factory to learn about something new and also something interesting. So well, let's go!
Wheels on the bus goes round and round, round and round, round and round. The wheels on the bus goes round and round, all town.
Wow! So students, this is where magic happens. Your delicious margarine is made here. So we are going to learn all the processes and reactions that occur to your favorite margarine. So some of you might wonder, what is so important about margarine? So I am very sure that most of you has a tub of margarine at your house. So you've probably seen it so many times. Your mother using it during cooking your fried rice, baking cakes and cookies, and also as a spread on your sandwiches that you always bring for your lunchbox. So now, are you guys more excited to learn? Woo, let's go!
Yes, teacher, we're so excited!
Well, kids, say hello to the manager of this factory, Miss Sri. Woo.
Hello students, welcome to our company. I am the manager of this company and you can call me Miss Sri. As your teacher has briefed you, this is where our margarine is made. Does anyone know what margarine is made up of?
Oh, I know. It's made up of vegetable fat. But miss, I thought the vegetable fat should be liquid at room temperature. So why is the margarine at home solid instead? Is there something wrong with my margarine at home? Should I get a new one instead?
That's a brilliant question. What a wonderful observation you made there. As you know, margarine, unlike butter, is made up of vegetable fat. So, how can it remain solid at room temperature? Now, this is what we are going to learn today. Teacher, would you like to explain to the students?
Thank you, Miss Sri. Students, remember we had learned about converting unsaturated fatty acid, which is liquid at room temperature, to saturated fatty acid, which is solid at room temperature. So that process is called hydrogenation. So what is hydrogenation? Hydrogenation is a chemical reaction between molecular hydrogen and another compound element, usually in the presence of a catalyst, such as nickel, palladium, or platinum. It is to saturate or reduce organic compounds. So can anyone give me an example of a catalyst used in hydrogen? Alyssa, what about you? Would you like to try?
Yes, teacher, I want to give it a shot. So, catalysts are substances that are added to increase the rate of a reaction. So, metals such as nickel, platinum, palladium, and their oxides, these are common catalysts for the process of hydrogenation. Although catalysts aid in speeding up reactions, they remain unchanged even when the reaction takes place. In other words, the amount of catalyst added into any reaction, they will not be reduced or be increased after the reaction has taken place.
Wonderful, Alyssa. I want all of you to keep in mind of what hydrogenation is because we are going to see the whole process of how margarine is made using hydrogenation, okay?
Okay, teacher, can't wait to learn.
You students are really smart. Now, let's not waste any time. I welcome you to our factory where the magic begins. Thank you, Miss Marsha, for a brief introduction of hydrogenation. Now, let's move on to the process of hydrogenation. The hydrogenation will always be carried out as a batch process. First of all, the hydrogenation is carried out in the presence of three reactants, which is unsaturated oil, a catalyst, and a hydrogen gas. The hydrogen gas is dissolved in the unsaturated oil, where each absorbs unsaturated fatty acids and reacted with a hydrogen atom to complete the saturation of the double bond. Then, it will twist it to a higher melting transform or shift to a new position. Then, the unsaturated oil mixed with hydrogen gas pressures in the presence of a solid catalyst. Then the hydrogen gas dispersed in the oil. Hydrogenation is an exothermic reaction where when the temperature increases, it has to be controlled by cooling until it reaches partial hydrogenation. The catalyst added was removed by filtration and residual catalyst will be removed in post-bleaching process. Partial hydrogenation, where a solid oil is produced after interesterification process. Moreover, to reduce the trans fatty acids on blood lipids, the food industry has practically eliminated components containing trans fatty acids from their fat phase composition. The application of partial hydrogenation as a method of producing solid fats has been reduced. So, full hydrogenation of almost all double bonds reduces the trans isomer content to an acceptable level but results in a product with a very high melting temperature. Such a product can only be used after interesterification with a liquid oil. This is a way of a healthy lifestyle. Let's move on to the mechanism that is involved, which is catalytic hydrogenation mechanism. Students, I am sure that you all will wonder how the catalyst helps in hydrogenation. Here it goes. Firstly, the carbon-carbon double bond consists of a strong stigma and a weak pi bond. Therefore, the reaction involves the breaking of this weaker pi bond. Then, the loosely held pi electrons of the double bond serve as a source of electrons which are easily available to the regions deficient in electrons. Then, with the presence of a metal catalyst like nickel or platinum, the H, which is 2 hydrogen bond, will cleave as shown in the slide. Then, each hydrogen atom attached to the metal catalyst surface forming the metal hydrogen bonds. The metal catalyst also absorbs the alkene onto its surface, to which the hydrogen atom is then transferred, forming a new carbon-hydrogen bond. A second hydrogen atom is transferred, forming another carbon-hydrogen bond, resulting in the new formation of saturated alkane. This is the way of mechanism in hydrogenation is carried out.
Now, let's watch a simple video so we can understand better what I just shared with you.
We have previously learned that an emulsion is a mixture of two immiscible liquids stabilized using an emulsifier. Margarine is a very good example of an emulsion. In this lesson, we will learn about margarine, what it is, how it is made, and a few key properties. Vegetable oils are polyunsaturated fats. You may be familiar with the term unsaturated to describe the presence of carbon-carbon double bonds within a hydrocarbon structure. So a polyunsaturated fat will have many carbon-carbon double bonds within its structure. These fats are normally liquids at room temperature. We can hydrogenate or add hydrogens to carbon-carbon double bonds via passing hydrogen gas over these molecules in the presence of a catalyst at 60 degrees Celsius. This is, and you got it, a hydrogenation reaction. When these fats are hydrogenated, they are hardened. Hydrogenated fats have a higher melting point, and as a result, are usually solids at room temperature. Let's think about margarine and what it is used for. It is usually spread on bread or used in baking. We can use a spoon and scoop spoonfuls out. Margarine is usually stored in a plastic container, and it takes the shape of the container. Keeping in mind the properties and consistency of margarine, do you think all of the double bonds are hydrogenated, or only some of the double bonds in the hydrogenation process? Please pause the lesson to think about this, and resume once you are ready. In the production of margarine, only some of the double bonds of the polyunsaturated vegetable oils are hydrogenated. This is called partial hydrogenation. Softer and easier to spread margarine is less hydrogenated, whereas harder margarine is more hydrogenated. Are you thinking about the taste of margarine now? Do you feel like toasting a slice of bread and spreading margarine over it? Here is a bigger question. Can you taste the saltiness of margarine? As mentioned in the introduction, margarine is an emulsion of water droplets in oil. These water droplets are in fact salty water. This is why margarine usually has a salty taste. The salt content of margarine can be modified. We can have low sodium margarine, regular margarine, and even salt-free margarine. The emulsifier that is commonly added is lecithin, the same emulsifier used to stabilize ice cream. In summary, margarine is an emulsion of partially hydrogenated vegetable oils and salty water. When vegetable oils are hydrogenated, a molecule of hydrogen is added across a carbon-carbon double bond. This hardens the oil, and the degree of hydrogenation can be varied to give softer or harder oils.
And that's about it for hydrogenation. Can anyone please give us a brief recap on what we have learned today?
Yes, teacher, I want to give it a shot. So, catalysts are substances that are added to increase the rate of a reaction. So, metals such as nickel, platinum, palladium, and their oxides, these are common catalysts for the process of hydrogenation. Although catalysts aid in speeding up reactions, they remain unchanged even when the reaction takes place. In other words, the amount of catalyst added into any reaction, they will not be reduced or be increased after the reaction has taken place. Not only that, hydrogenation is very important because it makes the food product more stable. So this means that the shelf life of these products will be improved when the highly oxidative unsaturated fats, they undergo hydrogenation. Other than that, hydrogenation will also improve the utility of food products. This means that the consistency of fats and oils, they can be altered through hydrogenation, which leads to the production of hydrogenated fats with different melting points. The melting behavior of fats can be influenced by the catalysts and the hydrogenation conditions used. Last but not least, hydrogenation will broaden the availability of edible fats and oils. An example to explain this importance can be observed through the production of certain types of fish oil. Hydrogenation helps make the fish oil taste more palatable for consumption, so it won't feel uncomfortable to consume something that is actually good for health. That's all.
That's nice, Alyssa. I'm so proud of you as your teacher.
Thank you, students, for visiting our factory. I hope you all gained some knowledge today. Bye!
Kids, before we go, I have a homework for all of you and you should submit it by tomorrow after our class. So answer these 5 questions based on what you have learned today. And the best questions out of all of you, the answer, I will give you a lollipop and also a tub of margarine sponsored by this company. So thank you, and I hope that you had fun for our school trip today. So see you tomorrow. Bye-bye.